of you waiting, sorry, I've got to share on YouTube, connect the live stream and all this stuff. So just 1 or 2 seconds. We've got some more attendees. Hey Melissa.
Hi, Melissa.
Hi Robin.
Hi, Robin.
Oh,
Welcome, welcome. We're excited to talk about compost. Are you?
Yes.
All right. All right. Hello, everybody. Welcome. Welcome to our webinar. My name is Christine Reiner. I am the Communications Coordinator Contractor with the South Dakota Specialty Producers Association. Thank you for joining our compost webinar with Zach Wright. This segment has been funded under a Conservation Collaboration Cooperative Agreement between the Natural Resources Conservation Service, NRCS, and the South Dakota Specialty Producers Association, SDSPA. The goal is to promote sustainable agricultural practices and environmental stewardship. Its contents are solely the responsibility of the authors and do not necessarily represent the views of the USDA or NRCS. All right, well, today with us is Lab Director and Compost Consultant for Living Soil Compost, Zach Wright. We're going to talk about some living compost, plant benefits, and like a bunch of other stuff. So welcome, Zach.
Hi, thank you for having me. Thank you all for being here.
Yeah, it's, there's no better way to spend a Monday than talking about compost.
I couldn't agree more. Or Tuesday through Sunday as well. Yes.
Every day. Every day. Yeah.
Every day you got to live and breathe it.
All right. Well, Zach, can you tell us where you're located and a little bit about your background?
Yes. So I am the owner director of the Living Soil Compost Lab. We're based out of Canton here in glorious South Dakota. Where the rent is cheap. That's why we're in Canton. We're on 104 South Main Street. You'll find us right across the street from Bushwhackers or Noid's video game bar. We're right across the street from there. Kind of by appointment only. However, we do all of our lab work here. We do lab analysis for the lower 48, some international work as well, specializing in biological assessment of soils and composts alike. We also consult also in the lower 48, mainly in the Great Plains between the Dakotas down to Texas, and then between the Mississippi River and the Rocky Mountains. And we work with everybody from master gardeners to large-scale producers in the hundreds of thousands of acres of row crops and broadacre rangeland pastures and the like. We fit into this niche movement that's happening right now in the regenerative space. Regenerative agriculture is very in vogue right now. It's very thought promoting, and we're also pushing a lot of envelopes in redesigning our whole crop systems. So we happen to help a lot of producers in that category with not only the biological composts that they're creating, but then how to deploy that organism-rich ecology back out into the landscape. And our largest customer is about 40,000 acres here in South Dakota. So for one, for a South Dakota piece, and that would be broad acres, row crops, mostly corn and beans. But we definitely don't seem to have a ceiling with the amount of influence we can help with. So we have people again from all over those states come to us, kind of like I was saying, by appointment, and they'll bring us a box of samples. We'll sit down, we'll prepare them all for them, and then I'll use the microscope here, and then I'll put it onto a big LCD TV, and then give them a big comfy chair to sit back, and then kind of like Jacques Cousteau, we narrate their systems for them, whether that's their soils or whether that's their composts or the occasional raw manures as well. We look at the digestive component of the animal and just qualitatively assess it through the microscope. So we're looking at our niche, kind of our nuances, that we're looking at the living component of your system, but at its very smallest scale. The microscope we use goes down to 400 total magnification. So we are able to look at 400 times the naked eye at a sample. And then based on what's there or isn't there, we can kind of come up with a evaluation, more of an interpretation of that system at that level, kind of that bottom of the food chain level, and then how that interacts with what we're seeing with our naked eye, because we have sick plants, we have plants that are infested with something, we have plants that are rotting. There's all kinds of things that we look at during the growing season. And it's amazing what producers of big scale, some of the extent that they go to really ask questions of their system and analyze it. I wish I did it more for myself, in my own sort of analysis. But, I have farmers that are doing weekly sap tests where they're obtaining actual plant tissue. They're overnighting it to the Netherlands, and they're looking at plant sap on a weekly basis and tracking that change over the course of the growing season, and then administering a solution usually based on some sort of nutrient that we're missing, or a cluster of nutrients that they're missing. So very
That's
real
so interesting.
time.
Can I ask a question?
Yeah, yeah.
Um, can you explain why they're going to the Netherlands specifically? Is there a
So
reason?
because of the exuberance of plant sap testing, it's still fairly new technology. There are a few labs now in this country. There's New Age Labs, which is based out of Michigan. There's Apical Labs, which I believe is in Oregon, that's doing plant sap testing now. But the lab that's been doing it the longest is through a company called Advancing Eco Agriculture, AEA. They're based out of Ohio, and they kind of designed this whole plant sap testing program before everybody else. And so most of our clientele, since there's uses AEA to send their sap off to the Netherlands, where it's then tested in a very specific way, and then they get results within a couple days. It's amazing how fast it all happens. And then with
Wow.
that, they get a big sheet with a bunch of numbers on it, and kind of optimal levels based on whatever you're growing, of where you should be, and at this time of year. And then the producer makes the adjustment based on that sort of analysis. So it's expensive, and it's very labor intensive as well. I also work with producers, like especially in Iowa, where they have monkey soil, because any monkey can grow in that soil. I mean, sorry to any Iowans here. My daughter was born in Iowa, used to live in Iowa. I love Iowa, but they can grow really good crops there because they have very good soils for it. And so they need to do very little, I guess, is the point I'm trying to make. Whereas, down in the Dust Bowl, which is where historically in the 13 years that we've been operating as an independent lab, we've done the majority of our work. We've had a real strong calling to that part of the world, is the Dust Bowl. And ironically, I didn't realize that till about last year, when I started overlaying the Dust Bowl map with our client map. And it was like, oh my gosh, we are going into like the bullseye all the time with people that are just ready to learn something new and approach their system differently.
That's awesome. So the work you do is so incredibly important. Can you talk a little bit about just like, let's start at the basics
Mhm.
of kind of your expertise. How did you kind of decide this was your calling, or what you wanted to do?
It's a lot of different things. It's a long story. And for those of you who are here today, I have Kentucky lineage, so I like to talk. I'm very long-winded, so I'll get going and just start talking about all kinds of stuff. So forgive me there. Long story short, I feel like it was this expression of genetic potential. So my father's lineage was all farmers, and my father himself was a classical microbiologist who was instrumental in the ethanol industry in the 80s, where he went around the country and set up a lot of labs for the ethanol plants around this country, and even into, I think, the Caribbean as well. So, and he's a lifelong gardener, but his dad, and then all the way back like at least 5 or 6 generations, they were all farmers. Now, my mother's side was garbage collectors. So they were a third generation trash hauling company. And I was in my late 20s, and it just was this expression of just like, and I was an art teacher. So my original education was in K through 12 art education. So I was teaching art to ages, well, really preschool to basically adults, 18-year-olds. And it was just this, I found compost to be this expression of just artistic something. I really understood it. I understood how everything really falls into about 3 categories. And if you know what those categories are and where they fall in, you can really mix your material so that it breaks down aerobically, it breaks down quick, it composts. So I like to think that, I traded in my paintbrush and my pencils for just tactile working with what people call waste. And I like to promote that waste is food, as long as it is, um, if it's the waste of something, we could utilize that waste. And that's what we do when we get hired on to go onto farms is we identify the waste streams of an operation and we say, okay, like let's create a recipe so that we can create sort of a genesis of this material and break it down rapidly using appropriate means and measures with temperatures and really oxygen and moisture and create a life supportive substance that we can use in a myriad of ways. So it was just this fateful thing that just had to happen. But my mentor, which is one of the world's leading soil microbiologists, Dr. Elaine Ingham is her name, I met her in a grocery store. And long story short, I ended up being one of her direct consultants for about 3 years. And we worked together so well that she sent my family and I overseas. So we did work abroad. We lived in the English Channel for a year. We started a lab there to serve England, Ireland, and at that time, Europe, all things soil biology. And our visas ran out. We moved back. Long story short, we got to see a lot of the world in a very short amount of time, being one of Dr. Ingham's arms. So she was able to work through me for enough years and putting me directly into these everything from turf to orchards to vineyards, golf courses, all these different uh, things that I really didn't know much about. But from the aspect of soil microbiology and what we can do to create that sort of solution of what we've unfortunately damaged on that soil microbiology level through our modern agricultural practices, I was able to, I guess, help create that solution for the operation, no matter what scale, what size. And that was ultimately through composting. And then what do we do with that compost? And that's where we create these liquid kind of washes of the compost, which are called compost extracts, and then compost teas as well. So
Wow. What
it's
an
been a wild
incredible
ride.
story.
Oh, thank you. It's been a wild ride, and I'm really fortunate that I've been able to take my wife and my 2 children with me. We live in Sioux Falls now. We've been here since 2018. Love it. Love South Dakota. We're Nebraskans originally, but this work has
Oh.
taken us, it moved us a lot of times in a few years. So um, I'm confident that I can help about any scale and really reach about any age. I'll do ag shows and vendor shows in the wintertime, and I'll take my microscope with me and have that set up on the table. And it's amazing the interaction I get from the youth. I feel like the youth is really interested in the tool of the microscope. I mean, they've probably seen it at school or they're middle schoolers now, so they're starting to use microscopes. But the I guess teaching, having that background, fundamental education and teaching, I'm able to teach it at any level, these kind of basics of soil microbiology. And really what I mean that by that is the bottom of the food chain. Those bottom 3, 4 rungs of our food chain that we can't see with our naked eye, they're missing, especially in like row crop ag. We call it the gap. There is this trophic level, right? So bottom of the food chain, you have bacteria and fungi, which eat everything. Thank God they're here because they are creating oxygen for us to be here. So you have that at the bottom of the food chain, but then you have the things above that that eat that, and the things above that that eat that. And that's where we start to have nutrient cycling happen back up our food chain, because many of these bacteria and fungi, they're literally eating the rocks in our dirt. So there's soil, right, which is dirt and the organic matter and abiotic influences and all the things that define soil. Well, then there's dirt, which we all have at some, difference in clay, sand, silt, and clay in terms of particle size, but we all have the dirt. And embedded in that is much, in fact, I would argue most of our fertility, outside of nitrogen, which is the most abundant yet limited gas that sits above our heads. But most of those nutrients down to the scarcest level are embedded in our dirts. We have to have something that can consume that, which we do. That's what bacteria and fungi do. Ultimately, they etch the rocks and break it down, they digest it. But then we have to have something come along and eat that in order to unlock that fertility. Otherwise, The fertility is locked up inside their little tiny bodies. Modern agriculture has not looked at soils this way and production this way. We've been looking at how big and how much we can grow and how, much we can make from it. We haven't thought about the living component of our soil so much. So in redeploying those organisms that eat the organisms that eat the organisms, we start to move nutrients off of the rock material and send it back up the food chain in a plant available form. Thus, we have healthier plants. We have plants that need less inputs because they're healthier, they're not as sick. And before you know it, the farmer is really looking at a profitability and not so much, I got the biggest yield so I can go drink coffee with the crew every day. We get a lot of the fringe farmers, the farmers that have just had enough of the system. But at the same time, we also speak to master gardeners. We speak to elementary schools. We demonstrate all the time. Just to help people value add their waste streams and turn it into food more.
So, wow. Okay. If you've been sitting here listening to Zach with me, you understand he's an expert on what he's talking about. He's seen soil all over the world. Just having your presence here, is so valuable to us. And it's so intriguing. I love that you have the education part of it so that you can break it down piece by piece for us. And since you've been talking in my mind, you mentioned earlier there were three types of compost. Can we kind of go back to that and talk about that?
Well, there's three categories that
Or three categories?
all organic wastes fit into. And I don't mean like organic as in certified organic. I just mean they were made of nature and they're the wastes. They're the trash, as farmers sometimes refer to it as, after they harvest, that's sitting out in their field and blowing into your fence or into your yard. All of that material falls into three categories. And those three categories, as simple as, it's basically carbon and nitrogen. Every living thing has a carbon to nitrogen ratio. That's what we're all built of, mainly on a physical level. So you have your carbon component. That's category one. And this is, I literally say, I start at wood chips. Anything that is hard, dense, woody, even straw can be your carbon material. After you've harvested everything out of your garden and everything goes dormant and dries down, that is all what I would call carbon. So that's category number one. Those are your carbons. Category number two, I really like this one. This one is what I call the bridge to the nitrogen. This one we call the green category. The green category is literally physically anything green. That green tells us it has chlorophyll, it has sugar, it has energy. The green material in the wintertime can be hay. Stored hay is oftentimes the green material, or silage. So we're very busy in the winter making composts across the country, especially when we are up in these latitudes. We lack that fresh green material. So we have to improvise and we use green hay, which is just dried green material. That's your second category. So you got your brown, your carbons, and then you got your green, which is physically anything green. It can be your lawn. It could be the leaves that have fallen off your tree. The third category, and one of the most important, is the nitrogen. This is what we call the party food category. This is what creates a lot of heat in a compost. Has a tremendous amount of embedded energy in it. It's very high in bacteria. There's more bacteria biomass than anything else on our planet in terms of in the living world. Bacteria are going to be here a lot longer than our species are. So bacteria, which are these smallest dots or rods that we see in a microscope, bacteria are abundant in fresh manures. They know how to generate a lot of temperature because they're ready to digest. They're ready to break things down. So we take our brown, our green, and then if we have it available, we identify a high nitrogen component. Manures, seed is also another high nitrogen component. So you could go to your brewery here in town, your microbrewery, and you can get their spit beer mash, and that would behave just like a manure would if you wanted to build more of a vegetarian compost, which I personally do at home because I live in town. I got to watch odors, but seed is loaded with nitrogen as well. Very narrow C to N ratio, carbon to nitrogen ratio on seed. So those are your three categories. And then depending on what you have available, depending on what you're lacking in your system, you can kind of combine those three in combination in thirds, as simple as a third of this, this, and this, by weight, if you want to be very approximate. So Some people, like on a home scale, will take a 5-gallon bucket, or they'll get like 5 or 10 of them together, and they'll weigh out each of their materials. So they're hitting that exact third ratio of each. Oftentimes on farms, we'll use the bucket of the tractor, and we'll build by volume. We'll kind of build with our eyes that way. However, if they have a livestock scale or a big scale, they will weigh their proportions of each, and then we mix those together. And there's a number of different ways that we teach people how to make their own compost, but this sort of recipe with the three like that will generate temperatures. And so we'll stick a thermometer in there. It could be a little 18-inch thermometer you get at, I don't know where in Sioux Falls you can buy them, but you can sure order them. A compost thermometer. And then on like at scale, we use a 4-foot thermometer to basically do the same thing. And then we stick that into the pile. And then daily we go out and we look at the temperature of the pile. What does that pile's fever look like? Now we want the temperature, we want that fever in the pile, because that temperature is helping really sterilize the pathogenic organisms that are obviously contained in a lot of our waste materials. So we want to kill the coliforms, we want to kill the E. coli's and the salmonellas and things like that. And we can be assured that we're killing those when we generate enough temperatures. So that sort of thermophilic method, I tell farmers this all the time. It's like marrying a pile or a windrow, however we're stacking our compost. It's like marrying it for a solid month in terms of you need to go out and check its temperature every day. And based on that temperature, you need to either add water or add air. And so that's where turning comes into play. And so when we do it that way, we can turn it effectively so many times, 5 times according to NOP regulations. And we have what's called organic compost. If we were organically certified, so we were having the organic stamp of approval put on our crop, we would meet their criteria with some pathogen testing as well afterward, that we've effectively killed the pathogens in that compost. We've generated the temperatures to create enough turns that we have sterilized the media so it's safe to use. That was a mouthful. On a home scale, even we see more static composting done, and that's basically where we're just stacking our compost up. And so that becomes kind of a dance of just having like a couple leaf bags next to your bioreactor or your cage or your bin, whatever you're composting in. I'd like to have like some of those, whether it's in a plastic bag or it's in one of those big paper bags, but just have leaf material in there. That's your carbon material, because as you add your food waste, your kitchen food waste is largely nitrogenous. It's very nitrogen rich. So as you're adding that material and scattering it in, you can grab a couple handfuls of carbon and mix that on top and literally just layer the material over time. If you start smelling funky odors, then the nose knows that's not a good thing. That's the smell of fertility going up into our atmosphere, and that's telling us we don't have enough oxygen in our material. So typically when that happens, or we start getting gnats and flies that start to accumulate in our compost, we need to take something and literally either take our pitchfork and we need to fluff it and turn it, or we just take like a piece of rebar or like an old tool handle and we just poke holes in it and allow it to breathe, because oxygen is critical when it comes to composting. If we don't have oxygen, it's not composting, it's rotting. And there are ways to compost without oxygen, fermentations. But that's kind of for the home gardener, for the applicable, person that doesn't want to put their food waste and their mail and all that. Oh, I mean, you can recycle it or you could use it as a carbon material. But for the person that doesn't want to send all of that stuff down their garbage disposal, or God forbid, put it in the garbage can, and they want to capture it and say, turn it into something new, especially if they grow plants, then it's very easy to do with just having that material go out with a little bit of extra carbon material that you're layering over time. And you can compost pretty effectively at a very small scale without your neighbors even knowing it.
Oh, wow. Well, my neighbors would love that, right? Everybody else in town.
Yes, yes.
Right? Yes, Canton actually. Yes. So we did get a few questions here, and one of them is kind of relevant to what we're talking about. So this one's from Robin.
I, Rob.
She goes, "What are your thoughts on the bokashi composting for people with small yards or in apartments?
Absolutely. Bokashi is, well, I think it's a Japanese technique originally, but the Korean natural farming movement's really taken that on. And it's a step-by-step process. And if you follow those steps, so like I think it's now called natural farming, but it used to be called Korean natural farming, and kind of the American ambassador was Chris Trump. I'm actually wearing a Chris Trump sweatshirt today. So Chris Trump's based out of Hawaii. What does he grow? Macadamia nuts. And he consults all over the country, well, world as well, teaching people how to culture their own indigenous organisms. So it starts with, they call it IMO, Indigenous Microorganism 1. So step 1, you would take you could take cooked rice and put it in a colander and go bury it in the forest, go bury it in your yard, ideally bury it under a tree where you're just cutting into the top horizon of your soil. You're setting that colander down in there. Then you could put leaves over the top of that, and then you just let it infiltrate with all the organisms of that surrounding area into that colander of rice for about 2 weeks, I believe. And then you take that to step 2, which is where you add equal amounts of sugar. Step 3, that's when you make the bokashi, or IMO 3 is what they call it. But bokashi, I think, is great. I guess if you're making it or if you're sourcing the bokashi, bokashi is largely fermentative organisms. So that's going to help reduce odors, especially if you're in a really tight space and you're adding a lot of wet food material and not enough carbon, for example. That bokashi is going to help infiltrate that, and it's going to help pickle it. And it's going to help it break down a little bit slower than like an aerobic method would, which means it has oxygen with it. But it's also going to help it break down a lot quicker and ultimately reduce the odors. So I'm only scratching the surface on bokashi, but I do have a producer in Iowa that does it on about 1,100 acre scale. So it can be done and really scaled up and done correctly.
Oh, wow, that's so cool. Thank you for that great answer. Um, Post-consumer food waste. Is there a contamination concerned in finished compost that uses this material? And does your lab look at contaminants in compost like those that persist after hot composting?
That's a great question. And I think that's a world that we still have to explore more into. I do advise all of my clientele that's going to be using it that we do go further, and we do heavy metals testings. We also do pathogen screenings as well. We do that with an affiliate, well, several affiliate labs that we sub that work out to. In our lab, we basically are looking at functioning organisms, and we can see we can see certain parasites as well through a microscope, but a microscope is very limited, and it's not really in its scope because you're literally looking at what's there and you're looking at everything. But, if you wanted to look at a specific type of, say, I don't know what I should say because I'm on camera, but there are certain persistent chemicals that are used in agriculture. And so oftentimes people will call us and they'll say, well, I want this I want this off of my farm. I just bought all these calves from the sale barn and they seem sick. I wonder if if this medicine was used on these calves, because if this medicine enters into my pastures, I'm going to lose my dung beetle population. And so there are labs that exist that you can send that material off to and look for those specific asides, we'll call them. It's expensive. It's definitely worth doing if money is no object, and also it's something that does concern you. Um, yeah, there's a lot that could be said on that component. However, at home, just speaking for myself and all the testing, excuse me, all the testing that I have to do every year, because I'll sell our material as kind of a sourdough starter for all scales of compost production, because we have been recreationally, I call it, composting now for the better part of 13 years straight, where we're carrying the culture forward. We're constantly inoculating it, and we're adding new material all the time. I paper shred everything. There's not really any paper or cardboard that goes into the recycling bin because that's a carbon material. So I know there's a lot of speculation with inks and also paper anymore having fiberglass in it, not to mention other, PFAs and other chemical components in the paper that could be attributing to sort of any sort of toxicity. But I'm using the organisms to digest it and ultimately turn that waste material, that raw material, into humus again. Humus is living topsoil. Humus is kind of, if you read academic papers about, okay, well, where does our steroids and where does the hormones that are in our waste streams, that are getting flushed down our toilet, where do they ultimately end up? It's humus. They end up attached to these hyper decomposed, then recomposed compounds of carbon, hydrogen, oxygen, nitrogen, which are called humic substances, humus substances. And that's the little brown cottage cheese material you'll see in the forest floor when you remove the duff layer. That's ultimately what I'm banking on my material ending up in, is attached to one of those and almost held and chelated by just the artifact of compost itself, which is the humus. So then, when I spend several $1,000s a year having stuff heavy metal tested and having it pathogen tested and having everything that I can have looked at tested by affiliate labs, ultimately nothing comes back as dangerous at all. But you have to be aware of it. I would say your water, what you're using as your water to water your composts at your home or acreage, whatever it is, should be considered. Is the water being chemically treated with chlorine or is it chloramine? And if so, what are you going to do to offset that? And I'll give you an example. So I live in town. Our municipality in Sioux Falls treats water with chloramine, which is a very persistent bleach, basically. When we went and so we bought a house a couple years ago. It had an old pond. We took it all apart. We rebuilt it, put everything together. We filled it with water. We went right to the pet store. We bought 20 goldfish and we put them in, and they all died like that. And that's because of the city water containing those sterilizing agents, which it is what it is. We went back to the pet store and explained the situation. And then kind of simultaneously, it was like, oh yeah, I know exactly what happened. And we had to get a water conditioner, which was a specific type of bacterial culture to add into the water at a very small rate in order to offset the chemical damage that was latent in that water so that we could then have fish live in there. And this is the same water that we're watering our lawns and watering our plants with. And hopefully nobody here's drinking it. I would not drink out of the tap water. That's nothing against the city. That's nothing against the powers that be. But don't drink tap water because it is loaded with all kinds of stuff, not to mention agrochemicals as well. So
Yeah, and I'm glad you brought that up because the city of Sioux Falls does mail out a water testing.
yep.
We got one earlier this year, and that prompted us to test our water. So if you're concerned about this, you should be. Even if you're not in Sioux Falls, wherever you are, you can get them on Amazon. They're little water testers, and they tell you how many things are found or whatever. And it was eye-opening for us. So we haven't really drank our tap water since, which is, a whole nother thing.
Yeah, but what is the solution to that? How do you offset those chemicals? Carbon. You buy an activated carbon charcoal filter that you can purchase them for your hose. You can purchase them for your kitchen. We have a Berkey water filter. I have several, and we filter all of our water through carbon. And that's exactly what we're making when we're composting. We're making fused, broken down, compressed, decomposed, then recomposed carbon. And that's where your humus substances come in. Because you give humus about several million years, or let's just say a lot of time and a lot of heat and pressure, you have charcoal again. I mean, you have coal again. So it's this kind of final stage of decomposition that we're going to arrive at in our lifetimes to break things down and package them into a humus form, which ultimately acts as a filter. So this is the type of stuff that we put into, you put a handful under your plants in your backyard, or you could put it in a sock and wash it into a bucket of water and pour it on all your plants. Not only are you populating that with the microbes that you've essentially grown in creating that material, but also you get all of the humic substances, the fulvic acids, humic acids, things like charcoal that ultimately filter. So it's kind of a broad solution composting can be to, in my opinion, all growing systems. We just have to have a way to apply it at whatever scale we're at.
It kind of permaculture just went off in my head, like it's a whole flow of design and how you best set yourself up for the environment you have.
Yep.
Um, and it's we also have, for those interested, we have a rainwater collection webinar and a biochar webinar on
Nice.
our YouTube. So while
Nice.
you're talking about that, I remembered my past conversations with those experts, and they're very interesting. Please check out our YouTube. But to go more into it, Zach, can we talk about, say, like a small scale producer? How would you set them up? How would you recommend they get started? Well, actually, before we do that, can we answer one more question that came in?
Sure.
So this is from Alex, and Alex is wondering, have you tested or used compost from the Sioux Falls landfill in town? Any long-term concerns, or would it eventually adapt to the environment once the microbiology adjusts?
Ooh, I haven't looked at any physically this year. I have looked at the reports multiple times. I work with a few market farmers around Sioux Falls who've shown me several annual reports. There are things in that report which, again, I just don't want to ever come off as like slanderous or anything like that. But there are components in there that concern me, yes. So when people contact us, we're kind of an exchange station of information. We don't have bulk bins of compost anywhere. Like I said, I have my own culture, but that's used very differently for a whole different webinar. When people contact us and they want tonnage of compost, on behalf of Living Soil Compost Lab, I don't direct them to the municipal waste. It's great that they're diverting it from the landfill. That's wonderful that they're creating what they're creating. The type of machinery, their protocol, I don't feel is assuring the health and safety of the finished product. I think that product is great for ornamentals. I think the city should be using it like crazy on their turf and their trees, but I don't advise anybody that's going to be raising things that they're ultimately going to be consuming to be using that material based on what I've seen in the analysis report that they will share with you because they have to. And these sorts of things are not, from our lab, we're looking at active biology. We're looking at the ecosystem of the soil or the compost alike. In years ago, in looking at it through the microscope, it was a kind of a compromised ecosystem, I would call it. It was very bacterially dominant. There wasn't many other things in there. So it's like on the microscopic world, it's like putting a bunch of rabbits into the ecosystem and no foxes or coyotes. There's nothing that's going to eat them. And those bacteria are going to take over. And yes, some of those bacteria are going to be useful, but it's not going to move the needle in terms of like a succession where we're creating a soil habitat where it makes more soil. Because that's like kind of the long and short of what we're trying to do is we're trying to mimic nature. And like the dung beetle, that's our company logo, we're trying to behave like the dung beetle in that we're amassing the waste and we're comprising it with intention to make it into something better, to make it into something life supportive. And we have material that can be used. I've lost my train of thought. Thank you for hanging out with me till this point, but I've just lost my train of thought. There's a lot to
It's
say.
okay. You showed me a logo, and I was right there with you. I was like, "Oh, dung beetle, that's
Um,
really cool." But
so
the organisms, about how they there's nothing to come eat them.
right, right, exactly. And so when you use a compromised compost like that, I would call it compromised. That's me that's saying that. And, they're doing a great thing. It's necessary to divert it from the waste stream. The windrows are there. They look okay. But on a microscopic level, I can tell a lot about the health, the ecology based on the ecology of the system. And so it's compromised. There's just a lot of bacteria in there, and that's it. I oftentimes tell this to farmers based on our modern agricultural practices, which are very dependent on chemicals, especially if we're conservation farmers and we're practicing no-till, we still have to have a way to control the weeds. So that means ultimately we're spraying a lot of skull and crossbones type agents out into the system, which is negatively affecting the ecosystem every time we apply it. What happens is over time, we observe from a microscopic level and then also a functionality level when we look at the soil chemistry that's decreasing every year, we notice that our systems are constipated. It's like our soils can't digest anymore. What we can generate through aerobic composts, especially through that active breaking things down and then recomposing them into humus structures again and fostering the health and livelihood of the organisms, we are creating literally a fecal transplant for your soil. So we are actually where currently we have a constipated system that I would say has more alike to like a superbug sort of situation. Like we've pummeled it with chemicals to the point and tillage, and I like tillage too. I'm not like a no-till guy, but we've pummeled that system. We've disrupted that ecosystem to the point where all we have left is a few bacteria who figured out how to mutate around that awful chemical thing that happened. And we have this proliferation of just a few bacteria that can handle that sort of toxicity. It's like a superbug. So these solutions that we can create through better soil health practices, through culturing our own organisms, aka composting, and putting those back out into the system is we're literally giving that system a fecal transplant, and we are re-enlivening the system so it can digest again and cycle. And it cycles nutrients back up the food chain. It breaks things down. Like you go into a healthy forest, the leaves are gone in a month. That's because the understory of that forest has loaded with fungi, which is very sensitive, is loaded with fungi that can digest that leaf material in order to feed itself again. That's just the natural way any sort of plant works. Well, that can happen in your backyard too. You can actually have those functioning organisms back out into your system via your wastes that you turned into compost, and you can have that system digesting itself again and ultimately growing the soil to grow. I mean, the soil growing the soil. It begats more life by doing it that way.
And so how could somebody start this if they don't have one? You know, say backyard, small scale, where would you kind of go?
I would keyword YouTube search vermicomposting if you don't know anything about worm composting yet. And I would literally go to Goodwill or a thrift store and just buy some old totes and literally buy a paper shredder, also maybe at Goodwill or Savers or a thrift store. I mean, keep it cheap, but you have a carbon stream happening in every paperboard of everything package you buy from the grocery store or thing that you buy. And yes, there could be some nasty stuff in there. I guess we'll cross that bridge when we get to it, but paper from your mail, all of that stuff can be shredded and used as a carbon source. And so literally you can fill a tote with that material. You can then start putting food scraps in there and then go online and order red wiggler worms, or go to the fishing store and see if they have red wiggler worms. That's Einsenia fetida is the name of the species. It's not an earthworm. It's not a night crawler. It's a red wiggler worm. But you can order them by the pound online and literally throw that in the tote and put a lid on it. And, you know, after watching the video, there's a few more things in there. You'll want to drill holes in the bottom so that it can drain and that sort of thing. But literally start there. Start with a worm bin in your house, and you can start to divert so much of your own waste into that worm bin. And there's so much content on YouTube. I mean, I just can't stress enough. Keyword search worm compost, vermicompost. That's VERMI compost, and start there. That'd be the easiest way on an urban, like super tight, I got a patio sort of setting.
I love that. And in the comments, somebody actually asked about our biochar link. So what I've shared is our YouTube playlist to, we've done many interviews just like this with other professionals. And so Zach's is going to be added to the playlist, but I've shared that in the chat. And we've got biochar, we've got tomato diseases, we've got a lot of stuff. We've got even ways that you can connect to NRCS funding if you want to talk about conservation, or if you want to become more innovative in the land that you have and work on, more healthier concepts for the environment. NRCS is absolutely who to contact and go through. Zach is a really great resource. Zach, do you also sell compost?
I do, but it's more of like as a culture, like I was saying, kind of a sourdough starter. So it's egregiously priced because of it, because I can only make so much of it in town, and because we do travel to a lot of places in the country to start composts. I do sell it by the pound. They make an extract out of that material, and then they'll inoculate tons and thousands of tons with it and infiltrate it with the diverse species sort of ecology that we've had DNA sequence, so we know we have some of the higher diversity material that's out there. And that
That
gets
is
them
so
down the road.
cool. A sourdough starter for compost. That
Yep.
is so cool. I
Yeah.
don't.
Yeah. That's a, like I said, I'm a recreational composter. My wife and kids will tell you I always have the weirdest stuff, bones to partial carcasses to dirt from a random ditch. I don't know. The, the, the road has been really long, and in that process I've accumulated a lot of different ecosystems. And then as a testing lab, we also incorporate most of what we test also into our own culture, which again we're annually having tested to make sure everything is safe and clean, because that's what we're promoting things to be done on the up and up and very transparent. We're not trying to be dodgy about anything, but we keep human waste, so we keep poop out, we keep dog poop out. We keep cats as far away from the pile as possible. So cats do tend to like compost piles, not bashing cats at all or anything like that, but they do contain a particular pathogen. The toxoplasmosis bacteria is a real thing. And like I tell people, because it's often, I'll go into a farmer's shop, there's the 10 piles sitting there that we built the previous season, and I'll reach into it and I'll grab a handful out and I grab a cat turd. And it's like, are your cats, you're not keeping these covered, because I'm always very explicit. You need to keep your piles covered. We can't have cats using the bathroom in there. It's not a detriment to the crop per se, but it's more of a detriment to us animals, us human Homo sapiens species, to have that sort of pathogen contact. So just be careful with cats. I would say if you have cats, it wouldn't hurt to put an old carpet square or something over that so they can't get in there and use it as a litter box. But other than that, yeah, we keep human waste out, we keep dog waste out, and outside of that, everything is fair game. I just threw a big rabbit that somehow mysteriously wound up dead in front of our house the other day. Threw that in the compost pile, and I mean, it's already almost gone. It's just when you get that digestion component built up in your compost, you really can throw about anything in there. Not to be like weird, but
Oh, it's not weird. We are the people who are excited about that.
good, good. Let's hang out. Yeah, waste
Yeah,
is
let's do it.
food.
Let's become best friends.
Yeah.
So with just a little bit of time left here, what's one bit of advice, the best bit of advice you could give somebody, just
Oh,
whether they're experienced or not experienced?
oh boy.
I saw
I
you
would,
like, I can't pick one.
oh, this is always a tough question. I would say that it's not ironic that we call leaves leaves, because if we leave them long enough and we really kind of step back and let them do their own thing, in a matter of a year, especially 2 years, you have one of the most beautiful life supportive substances. You'll make humus. So easy thing to do this fall is just take some fairly inexpensive black garbage bags. I mean, bags that are so inexpensive, you can kind of see through them. Like it doesn't even have to be like heavy duty lawn bags, but literally stuff them with leaves, tie them up, and then take a pitchfork or take your screwdriver and poke a couple holes in the bottom of the bag. So you've got it sealed up on top, and then you've got holes on the bag. Put those against the side of your house, put those underneath some trees. Maybe you have some trees in the back of the property, and just leave them be. Leave them be for a minimum of a year, but ideally 2 years. And when you open that bag back up, you will have some of the best humus, better humus than you can buy anywhere. Anywhere. Leave.
Really? And so what kind of a, you can use a plastic bag
Yep.
to do that?
Yep.
Wow,
You kind
okay.
of create this sort of biome inside the bag that holds the moisture, but those holes on the bottom of the bag encourage your night crawlers and your earthworms up into the bag over time. And so when you open that bag, you'll find you will have housed a bunch of those critters inside the bag, and they'll just tear things, shred things up and allow the organisms to break them down.
Wow, that's amazing.
And
Well,
I'm
listen,
saying
we
that
don't.
from a microscopic vantage point. So the vantage point that I'm basing basically everything that I'm saying to you today on is from that right there. So a microscope. So pretty crude. They've been around a long time, but technology's come a long way, and we can get a fairly reasonable microscope that's digitized that we can plug it into our computer or plug it into as big a TV as we want. And it's all effortless, smooth. And I mean, for $300-400, you could be your own expert.
Wow, that's much cheaper than an internet masterclass, let me tell you.
Right. Which there are those out there. I would advise anybody that wants to know more about this and like, let's say wants to do training from the comfort of their own home, definitely search Dr. Elaine Ingham. That's Ingham. She does a whole webinar coursework. Another one I really like is a gentleman named Matt Powers. He's a permaculture guy originally, younger guy, but also a background in education. He also does some great webinar type stuff, training people how to use microscopes as well. We also can train people in person. So we have farmers that come to us, we go to farms, and we train people one-on-one. We're kind of like the Cliff Notes. We've done it long enough that we really know the kind of the most important pieces that can really move us forward. But if you want to go more academic with it, with coursework and course material and take tests, would highly encourage you to check out Dr. Ingham's work and Matt Powers's work. Both are accessible online. You could watch videos for days with both of them on YouTube, I'm sure. So yeah, just want to promote that. But for the active learner that wants to learn in person, I'm happy to come and teach a group. I can handle about 10 people at a time. And if we can get 5 microscopes hustled up, which I have 4, then we can get 2 on a microscope. And within a day's time, I can get people trained up to use their own microscope to look at their own systems.
Wow, that's so cool. And so, what else, if somebody's wanting to get in contact with you, what's the easiest way to do that?
Just go to our website, livingsoil.net. And it's not the only reason to go there is it has a hyperlink to call, text, or email. The site was built in 2014. I am not a web person. We've been in lean startup always. So it's just a landing page. There's a lot of dated information there. But at least if you pull livingsoil.net up on your phone, you can hit the call, text, or email button. I communicate mostly over the phone because the average American farmer still just likes talking on the phone. So,
It's simple. It's straight.
yeah,
It's to the point. I often say any form of communication that somebody is comfortable with, I will go to. But as far as your website, this is great. I mean, it's
it's
I'm a
something.
marketer, and so I often say if it looks perfect, they're not gonna like sell out. But if it looks not perfect and like, you made it yourself, they're 100% you're gonna have more sales likely. So I don't know if that happens for you, but
That's
um
me. Yep. Yep.
little marketing tip for everybody. It doesn't have to be perfect. It's actually better if it's not.
Thank goodness.
Um, yeah, thank goodness. But I want to thank you for your time today, Zach. And I'm really glad that we were able to reconnect. Life
Yes.
happens, and so it's been such a great hour with you. Sorry, my computer technology. My computer is getting a little upset with me right now.
Uh-oh.
Yeah, uh-oh. But for anybody who wants to get in contact with Zach, if you didn't grab anything from the chat today, we'll make sure to have his website and his contact information in our captions. So you can always come back to our YouTube and watch these videos. You can always reach out to Zach. And then at the end of this, there'll be a short survey kind of asking for your feedback. We are grant funded, so that helps us gauge kind of your interest, maybe other things you want to learn. It also lets us know if we're doing a good job. So if you got a few minutes, please take care of that. But otherwise, Zach, I want to thank you, and I want to thank everybody else for dedicating their time to this.
Thank you.
Yeah, when you take the actions to show up and to educate yourself on something new, I think that that's the most commendable thing we can do as a community. So again, this segment has been funded under a conservation collaboration cooperative agreement between the Natural Resources Conservation Service and South Dakota Specialty Producers Association to promote sustainable agriculture practices and environmental stewardship. Its contents are solely the responsibility of the authors and do not necessarily represent the official views of the USDA or NRCS. Again, my name is Christine Reiner. I'm the communications coordinator for the SD Specialty Producers. And if you want to see more, or we're always hosting events, more webinars, updates. We have this really interesting organic chapter that just started. So, to kind of piggyback off all the things that Zach was talking about today, if you want to transition into that program, the South Dakota Specialty Producer page or website is the perfect place to go. If you have questions, my email is open, and our social medias we're very active on. So join us at our next events or webinars, and if you're interested in more, just reach out to us. So thank you all again for your time.
Thank you.
Yeah, have a great
feel
day.
free to reach out in any way with questions. I'm happy to help in any way I can.
Yeah, maybe like how do we get more traveling contracts like Zach?
Have soil will travel. Hey, I mean, we need more people that are actively engaged in this because we got to eat, right?
We do, and climate change is happening. It's real. So I hope that we have more of you, Zach. I hope that we bring you back on maybe for our conferences or other webinars because you have been so insightful today. So thank you for your time.
Thank you. Thanks for having me.
All right. Bye, everybody.
Everybody have a great week.